Welcome to the grade 7 class, the NS class for K2 Primary School. Today we're going to talk about potential and kinetic energy. So you can follow me in your textbook on page 104 up to page 109, and I'm also going to use the notes as we go along. Okay, so firstly we need to talk about potential energy. Potential energy is stored up energy, and energy can be stored up in three ways. Okay, so firstly, elastic potential energy. Elastic potential energy is stored up in something that can stretch, an elastic band for example, or a rubber ball, or a spring toy, or an air gun. All of those things consist out of things that contain elastic potential energy and actually functions in that way. If I think about somebody that uses a crossbow or use a ketty, for example, so when I need to stretch something, I know that thing contains elastic potential energy. The second way of having elastic potential having potential energy is positional potential ppotential. But positional potential energy is because of an object's position. If the object doesn't make contact with the floor, for example, you sitting on your desk in class, your pencil bag on your table, your book on your table, all of those things consist or have positional potential energy because of their position that have been lifted. The things have been lifted from the floor. Okay, so with other words, if I think about a stone on top of a mountain, or I think about a brick on the second floor, all of those things got positional potential energy because of their position. Okay, so the last last type of potential energy is chemical potential energy. Chemical potential energy is locked up in fuels, for example, petrol, diesel, coal, and gas, for example, that by a chemical process they can release this kind of energy. So chemical potential energy is found in such fuels that releases this energy by a chemical process. Okay, so let us proceed. The next one is kinetic energy. Kinetic energy is movement energy. So movement energy is any object that moves have kinetic energy. So if I think about a stretch elastic band which have been released and it flows through the air, that have kinetic energy. If I think about a weight rolling off a table, a ball rolling, a turbine that is being blown in a pipe, that's turning, that is things that consist that have kinetic energy. Water flowing through a pipe, a car moving, you walking, you running, electricity going through a wire, that is also kinetic energy. So all of those things is kinetic energy. So let us have a look at the figure 6, A and B on page 106. Let us have a look there. Okay, so here is a system. Now a system is many parts that work together to actually let a specific thing happen. If I think about a system, I think about a bicycle. A bicycle consists out of pedals, a chain, some gears, a steering wheel, a seat that we can sit on. So many parts forms a system. And as all these parts work together to let a certain thing take place, or let the system work in a certain way. Okay, so what is happening here is we are looking to potential energy changing to kinetic energy. So firstly we're going to start with the man, figure 6 there, 6A, the man that have the ball. So what happens is the man pushes the ball. The man pushes the ball because he had from the first place chemical potential energy, and that is converted into kinetic energy, and that is why it's able to move. So the ball on top of the mountain has positional potential or gravitational potential energy, and that is actually released into kinetic energy, and the ball rolls from the mountain. So here at B, they just illustrate to you what is actually happening further. So chemical potential energy changes to kinetic energy and so forth. The same with figure 7. Figure 7 is an elastic band. So what happens is the man changes his chemical potential energy, he changes it to kinetic energy. When he stretches the band has elastic potential energy. That kinetic energy, when he releases the band, it actually changes to kinetic energy, and the band is moved by the elastic potential energy. So this is how energy changes in our everyday life every moment. Okay, so let us have a look at different kinds of systems. So the first systems that we find in is a mechanical system. A mechanical system depends on the input energy. If the input energy is from motors or machines or springs or stretch elastic materials, like for example a crossbow, it will be a mechanical system. A bicycle will be a mechanical system. A car will be a mechanical system. All those things that have the input energy from motors, machines, and so forth. Then we got terminal systems that are heating systems. Whenever the input energy is from heat, for example, a candle that is burning, wood on a fire that's burning, the transfer of heat from a cup, a warm cup of tea, into the air, that is a thermal system. All of those things, a gas stove, a gas heater, for example, all of those things are heating or thermal systems. Then everything that works with electricity. Everything that works with electricity, so the input energy is electricity. That is from, for example, a cell, a television, a stove, a microwave. All of those things are electrical systems because they work with electricity. Then lastly, biological system. Biological system is a system where we have the input energy is plants that is being eaten by animals, for example, a food chain. That is a very good example of a biological system. And so this is our 4 kinds of systems that we find in NS. Okay, so lastly I'm going to talk about the law of energy conservation. Now the law of energy conservation states to us the following. Number 1, energy cannot be created or being destroyed, but only change from one form to another. And it is just what we have explained, that we have potential energy. This potential energy is changed into kinetic energy, is changed into chemical potential energy, and so forth. So energy changes every second of our day. Okay. So energy is transferred in a system. So make sure that we understand that energy is transferred from one place to another. Okay, so we are going to have a look here at the diagrams of page 108 and 109, how energy is changing constantly, how energy is transferred in a system from one place to another. So I hope you have learned something, the different kind of potential energy. We have learned about kinetic energy. We have learned about the 4 different kinds of systems that we find in NS. So make sure that you understand how energy changes from one form to another. And also the most important here is also the law of energy conservation that states that the energy cannot be created nor destroyed but change from one form to another.